All right. So yeah, this is our section 2, right? So I think I was talking to Thomas just earlier, and I talked to a couple of you guys already during our one-on-ones. Ideally, in a perfect world, you guys would be completely done with the section before the study group. Realistically, it's probably not going to happen. There's so much going on, especially for part-time. I think most of you guys, when I talk with people in part-time, usually the expectation is that you guys will have more time on the weekends. And that just means that you'll have the section to catch up. So what I classically do is in the study group, which is dedicated to one section, I won't go through the whole section. I won't go through all the topics, but I'll try to focus on parts that I feel are really important, or at least parts that that I feel like it's like, oh, this is something that we can really talk about. And I'll say sometimes when we're going through sections, you can check this out, or go into the section and curriculum, really understand those parts because they'll go into more detail. Again, the curriculum usually will have much more detail than I can give. And of course, if you guys find that there is, like if there's a better way I can present the information, then you let me know. And I think I talked to Rudy about this earlier today, is giving basically a feedback information, like a feedback format. So I'm working on that and seeing if we can have something where you guys can give me feedback and let me know. I was like, oh, I really like this. I didn't like this part. And again, I won't take offense if you say, you suck at doing your presentations or, your study groups. I'd rather do it this way. I won't take offense. Maybe don't use the word suck, but, whatever you feel. All right, guys. So a couple things we talk about before we go right into the section. Friday feelings. So that it's on Friday. That's every Friday. Just like we have our study groups. It's kind of a normal. And that's kind of a section, if you're wondering what exactly that's supposed to be. It's basically a time where we can talk about stuff that are beyond just the curriculum. Sometimes, for example, I have one study group who likes to talk about Game of Thrones. They're really big Game of Thrones fans, and they'll talk about it basically as students. And I haven't watched any Game of Thrones, which people just go gasp and say, what? How have you not seen any of it? But it's just, it's just not my thing, I guess. So I'll kind of sit back, and listen. Just a way for us to chat. I think it's a really useful way for us to feel much more like a classroom. We're all scattered throughout the world right now. So it's kind of nice to be able to kind of take a second, relax a little bit. And sometimes it naturally will talk about, data science in general, but it's not a strict reason we need to talk about anything in particular. And sometimes I'll give information about, by the way, I released the curriculum, look out for these kind of things, but, stuff like that. So that will happen, was it tomorrow at, I believe we're scheduled, does anyone know actually on top of my head? I think it's 7 p.m. Eastern time. Yeah, Eastern time. So same time as this time right now, which is right, 7 p.m. Eastern. I'm in Pacific Standard Time, so I always forget what that is. So anyway, just look out for that. Any questions you guys have? I thought I heard someone say something. No? Cool. All right. And then one-on-ones. I've already had one-on-ones with Andrew, Rudy, and then who else did I see today? Nicole. So I think everyone else is scheduled right now. Thumbs down if I don't have one scheduled with you. I'm pretty sure. Cool. All right. So I think the rest of you, I'm seeing you guys tomorrow, and we'll have a quick 30-minute talk and everything like that. Quick thing, resources. I have the first video out from our recording. I usually try to put it within a day, so this will hopefully be out tomorrow. Yesterday I had some issues with internet, so I didn't get it uploaded and stuff like that, and it's kind of getting pushed back further and further. But it should be up now. I'll update the resources as we kind of record them through, and any other stuff that we have new in there. Usually it takes a couple days for me to get it all in there because so many things going on. But I'll usually, if any resource comes out, I'll usually Slack it out first, because that's you guys are my go-to, okay, I'll Slack it out onto the specific channel, like I did today. Otherwise, what I do is I'll try to make the video just public when I publish it, and that way, if I don't Slack it out right away, you can at least see it directly on there. You can check the channel and just oh, the video's up. And then for Igor, for anyone, you can always see it on the student resources page once it kind of comes out. Okay. So yeah, so that's the resources and everything like that. And let's see here. I'm going through my checklist. Let's make sure I get everything. All right, cool. So that kind of brings us into today's. So I'm gonna send it through the Zoom chat right now, and I'll put it on the Slack channel too after the meeting or after our study group. Again, this is actually created again through Eli, one of the other instructors. He basically put together a few different, I guess I should share my screen. So let me share my screen real quick. I can never find which one's the other. There it is. Okay. So, okay, hopefully you guys can all see my screen now. You guys disappear when I do that. Okay, cool. So this is actually curated by Eli. He hasn't done all of these things, but I just want to give him credit because they're really good. There are a bunch of cheat sheets and stuff like that. Note this knowledge gaps, that's from another cohort. So you can kind of ignore that part of as the resources, but you can see there's the cheat sheets. For example, this one's talking about Django, which is actually a way to basically do some web development and stuff like that. We're not going to talk about it, but basically there are things that he had found at the time that he really liked. For example, we're going to talk a lot about Matplotlib, and Matplotlib is basically a tool to use to make graphs and charts, and it's a really powerful tool. It's also a lot of information that comes through it, so just be aware that like as we go into Matplotlib, usually I hear people say, I find everything's pretty good except for Matplotlib, but that's kind of like what we'll see a lot of. Okay, so and there's a few other oops, what's it called? Cheat sheets. So for example, it's for Python stuff. And these might be useful for either now or in the future, like in the near future. This, for example, talks about statistics, which is really useful. But we'll talk a lot about statistics. But you'll see things like covariance and stuff. We won't talk about that until much later, as well as like things like, for example, we'll talk about this like t-tests. Our t-tests will be later into like way into the other section, in other sections, not until I think at least section 10 and some other stuff. But these are nice to like hold on to, download. Some people really like them. They'll keep them like even as their desktop wallpaper because they'll find it really cool. Just go through it and just know that we're not going to go through all of it right now. But this will eventually be something that we'll touch all the way through eventually. Okay. I'm trying to think if there's anything in particular I wanted to point out. No. Okay. And then there's also Eli also put together this notebook, but I noticed this notebook is actually a combination of section 1, so from those last resources set. It's actually that notebook combined with it, and we'll actually look at it today. Just know that the second section is basically the same as the first from last study group. So just kind of be aware it's a repeat. Okay. But it can be useful to kind of go through in addition to the curriculum. Again, these are all additional resources on top of the curriculum because we're never done learning. We're always learning. Okay, so cool. Any questions about these resources or how to access this? Okay, cool. All right, and cool. Hi, Bardo. See you dropped in. Cool. All right, so I want to show you guys our first bit. So this actually is from the first section, but as you guys remembered last time, I didn't go too much into the first section where we talked about Python. At this point, I think you guys will hopefully have used Python at least a little bit, so have the concept of like these parts from the was it the pre-work or the prep work, that kind of stuff. So I think hopefully this is not all new to you kind of stuff. Real quick, thumbs up if you're set up on your machine. I know we had some issues before, so thumbs up. Okay, I see Barbara there. Thomas, hopefully you're set up too. I know you talked about your multiple computers. And shout out to Ali, by the way, who put together that doc right there. That was really awesome, Ali. Thank you for sharing that. Especially for the record, I don't have a Windows computer, so sometimes those issues come up that are specific to Windows or a specific computer system. Use your classmates. That was perfect. And it was great to see how everyone going through. For the record too, I had a lot of other instructors who launched a cohort. We were saying the same thing. Most of us didn't have Windows computers. We're like, we're having these issues and everything like that. So always good to like share that information out. So cool. But anyway, good that you guys are all set up. The learn environment, that just basically makes sure we don't have to do extra installs. When you're actually in the professional field, you will use virtual environments to make sure that basically you can keep it like essentially like your own little corner of like information, like packages. So one thing is like, you can do, for example, install all the packages you want on your computer, but you'll see this more and more as you kind of do more of this coding, where people will say, well, it worked on my computer or it worked on my machine. And that just becomes really, really common. So we use virtual environments to kind of keep things a little more quarantined, so we know exactly what packages are interacting with what. Because otherwise you might have issues where it just doesn't work well. So that's kind of like the reason why we use our virtual environments. But for the most part, we're only going to be using learn environment, the learn-env. Okay. So this kind of goes now that we have the learn environment going through, we can actually start doing some Python. You actually don't need the learn environment to do most of Python, but when we get into more packages, we'll do that. So hopefully it's also kind of review. So I'll go through it really quickly. If you have questions, just interrupt me and just say, hey, you know, I don't quite understand this, or like, why did you do it this way? So note that in Python, we can always basically make these variables. And this equal sign for Python is basically our assignment. We'll use Python nearly exclusively throughout this whole course. It's kind of like the data scientist like tool belt. It's like what everyone essentially uses nowadays. Funny enough is that I used to, when I first learned Python, a lot of people were saying, oh, Python's really slow, but at this point computers are so fast, it doesn't really matter. It's so insignificant. And we'll do certain things that actually speed up the process, which we'll get into called pandas, NumPy, and basically all this stuff. Kind of an interesting thing about Python. Has anyone heard of like C, C++ as a programming language? Yeah, so I see some nods right there. So Python's actually built on top of C and C++. And so when we actually will use like NumPy, for example, which we'll kind of talk about later, and pandas is built on top of NumPy, NumPy actually uses the C structure, the C, C++ structure, and which is able to make it go much faster and vectorization. And we'll talk about a little bit about efficiencies and stuff. And the reason why that really matters is as a data scientist, you're going through a lot of data, like very, very, very large data sets. Easily could be like 1 million data points, you know, entries in there. And so we have to be able to process that information very quickly. And if we have a slow way of processing it, it's just going to take more and more time and everything like that. So that's why we use these, we start thinking about these efficiencies. So again, data science brings up a whole lot of different, you know, technologies and different ways of thinking that you just have to kind of know. Okay. All right. But anyway, Python, we have our variable, we have our assignment, which is our equals, right? And then to the right of it, basically is what we're assigning it to. In this case, you know, this is right here is a string. Note that you can use single quotes. So of course this wouldn't work, but if I put double quotes in there, it would work in that case. These are both equivalent to each other. It's just another way so you can do like double quotes within, or single quotes within double quotes or something like that. So just be aware. So for example, if I want to put what is the meaning of, I don't know, say lives or something like that, this wouldn't work because that part would end. So you could either do a backslash to say, hey, this is actually supposed to be a single quote, not ending the string. Or what you could have done is essentially put double quotes around. And you always, it knows like, oh, that's just a single quote. It's not going to be ending the string. Another thing that we'll use too is multi-line. So if I have like string 3, I can multiple multi-line strings, and this would be single quotes or double quotes. They can, doesn't matter which one you use. You can actually have multiple lines like this. If you try doing this for, like if you try doing the same exact thing with single quotes, you'll notice that it won't work. In fact, when I try to run this now, you'll see, oh, and the file doesn't work. It's because it's expecting. There's some ways you can get around it. So like one thing, for example, you could do is put it in braces like this, but that doesn't always work depending on what you're trying to do. So that's where the multiple line string for Python comes from. So now I can actually run this part and you can see that string 3 will run through, and we actually try to print this out. Just kind of show you. Okay, oops, did I spell it wrong? I spelled it wrong. Not string, string, okay? And you can see there's these new lines here. Basically, it's just saying that. Note that, so this is actually a good point, is that in Jupyter Notebook, when I run it at the end of the line like this, it will, by default, try to do something called display on that last element. So if I put like string 3 here, but I've also put like a equals 1, what will happen is that this part right here will disappear. You won't see this part, and you can see that'll disappear. And that's because basically, Jupyter Notebook is trying to print out this last line, but it's not technically print. So as we talk about some of this stuff, you probably have seen this now, print statement like that. That will print it nice and pretty. What this actually calls when you have just string 3 here, it's actually calling display, which is slightly different from print. So just know that there's a slight difference of like what's going on. So if you want to print it out, that's usually what you would do classically. But if you leave it by itself, like string 3 like this, it's actually calling display natively. And there's ways you can kind of adjust this, but that's the default for Jupyter Notebook.
Can I ask a question about that?
Yeah, go ahead.
So at the end it says /n, but it's not within the triple quotes.
Mm-hmm. Yep. Was that your question? Just saying what is /n?
Yeah, like right at the end of the output here.
Mm-hmm.
It
Yeah.
ends
So
with a J here and it ends with a /n.
yeah. So you're probably asking like what that is then? Is that okay? Oh, you're on mute, Allie.
It's all the gosh, like when it goes to the second line, it's in all of them.
Yeah. So if I do /n, so they say like first line, and then I do /n. I'll do a space so it's easier to read. Second line. What that -n, just like if I put like a backslash single quote like this, if I can get it, there we go. A single quote like that. It's saying, hey, this is not anything. This is not just a single quote. It's supposed to be in the string. This \n is saying, oh, it should be a new line. So if I do a \n here and I do, for example, we'll just do print, makes it nice and easy to see. If I do this now, you can see it makes a new line on here. Also, you can do certain things like, for example, \tab or T is for a tab. So you'll see those indented in that way too. So whenever these are white space characters, they call it. So these are things that add extra information that you can put in here. By default, basically, these multiple line strings, that they're encoding for that \n. So there's, in a sense, there is a \n. We just don't see it when we write it out. Cool, good question. All right. So yeah, there's a bunch of things you can do with strings. Again, documentation-wise, if you ever see something like that, and you're just like, what is that? Go search for it. Go search like Python \n and see what comes up. And then honestly, you see either Stack Overflow probably or the documentation from Python. And reading documentation in general tends to be almost like a different language. So just kind of be aware of like what things are going to pop up in there. So cool. And then of course, going back to variables, we can name variables as long as they start off with a letter, which could be capital or lowercase, or an underscore. Though we'll note that the underscore tends to be reserved for, we'll talk about this later, but more for like internal variables that we don't want to access every single time. That's where we do the underscore, but you can start off a variable with an underscore and call it from there. Note, however, like, so for example, I could put a capital B right here, right? And I can just do, oops. I run this, right, and I'll get bool, which will just be true. If I do a lowercase b, note that, well, that's a bad example, because that's just bool. So let's say I do, I'm trying to give you guys a good example. Oops. So now I have that part. Note that this part will basically preserve that. But for completeness sake, usually we'll start off with a lowercase in Python, even though it would work fine. But we'll also tend to, like, if you guys know snake case versus camel case, have you guys heard those terms before? So just again, more computer sciencey kind of stuff, since as a data scientist, you kind of have to have a little bit of everything, right? You'll hear people talk about camel case, which is basically like, let's say bool is cool. So you'll see that I use capitals to kind of separate those different words. In Python, it's usually standard to do underscores. It's called snake case. So like we'll do an underscore like this. And that tends to be the standard of what we'll use and stuff like that. And you'll see me use it too. Sometimes I'll break away from it, but just be aware. Note, you can also put like numbers in here. You can put that in there. You cannot start it off with a number. It has to start off with either an underscore or a letter, okay? And then you can see, like we said, here's some numbers. In this case, this is a float. This is actually something called a Boolean, basically saying it's true or false kind of deal. We saw what printing looks like. We saw, this part right here, if I run this, it'll just print this part out because it's the last part. Note that it's calling display. You'll notice right here, they use this type bool. So this is a great way to kind of debug, say like, well, what is this type of variable? So in this case, it's saying, oh, it's a bool. Well, it's short for Boolean. So Boolean, basically, I believe it's from a mathematician called Boole, but I could be wrong. Back in the, I'm gonna get this wrong, but like 1900s, maybe 1800s. Fun fact, the guy who came up with Boolean logic thought it was a useless, interesting thing, but not really useful. Turns out it's what basically computers are built on today. So kind of fun fact. But anyway, you can see this type right here. We can also put in something like a string like this, like AS, and we can see that's a string. If I put in a number in here, for example, I put 1, anyone guess what that type would be? You see someone mouthing it.
Integer.
Integer, right? So int like this. If I do 1.0 like this would be a float. Okay. Note for Python, if you do 1 point like this, it's pretty smart, and it's like, oh, that's a float. You don't have to put the 0 in there. So you'll see sometimes people do like things like this. Okay. If I add two integers together, right? Okay, we obviously get an integer again. If I do this, we actually get a float, because if I actually try to do 1 plus 2.0, you actually see it's 3.0. So Python tries to be pretty smart. Sometimes Python kind of does a little thing, be like, you know what? I'm going to trust whatever you put in, programmer. I'll go with it, and I'll try to go. And sometimes it does certain little freaky things, but for the most part, it's pretty useful for how we want to proceed. Okay. So again, basic variables, that should be pretty review for you guys. This kind of goes into like doing strings. So for example, these are built-in methods or functions that Python has. So for a string, we can actually do a string.title. And does anyone know what this does actually?
It capitalizes the first letter.
Yeah, good. Capitalizes the first letter of each part of the word. So that's really useful. And then you can see like, upper. I think the curriculum actually has some of these stuff. So I'll let you play around with that kind of idea. So just know that there's a bunch of different methods that are built into some of these, like that's already built into Python. We didn't have to do anything special. It's already there. Okay. Again, these different types, we saw what those look like. So if you're curious, number, bool. One thing I should say, as you guys are using Jupyter Notebook, hopefully you guys have kind of got this, but I'm kind of going through it really quickly, is that when we want to run this part, there's a few ways you can do it. One is you can actually click up here, which actually will run it. I think in certain versions, you can actually click over here. There's a little run icon, depending what your setups look like. You can also do Control-Enter, and Control-Enter basically just runs that line without going forward. You can do Shift-Enter, and Shift-Enter will just basically keep dropping it down as you run them. And then also there's also Alt-Enter, and you do Alt-Enter, and that will actually make a new line, like a new cell for you. And we could put multiple things in here. I didn't have to keep these separated. We could put them all in one line, and we'll execute that whole thing. So these are just called cells. Just be aware of that. Okay. And there's different modes. The curriculum goes into detail. I won't go in there. And there's so much more. Sometimes I don't even remember all the little things that you can do. For example, you can split cells with certain keyboard shortcuts. But if you're curious, you can go to Help, Keyboard Shortcuts, and it shows you a whole list of things, and you can even edit these shortcuts. So good to know, not essential, but I think they can be really useful as you do the same stuff over and over and over again. Okay. So kind of going into some basic stuff since we didn't talk about it before. Then there's some data structures specific in Python. We have we have these ones, but we also have something called tuples, which wasn't in the curriculum, but we have tuples. So we have lists, dictionaries, and tuples. Lists are kind of exactly what you think they are. It's just a list of things. So we denote this with a square bracket like this, and then each item in here, each element we'll call it, is separated by a comma. So you can see right here, this first element is Solta, Greenville, Buenos Aires. Basically, just all these different strings, right? If I run this now, we can actually have this long list of things. In fact, if I want to now go in here and I want to do top travel cities, you'll see that it'll print out a list of these things. Note that they don't all have to be exactly strings. They could also have been like all integers or numbers or whatever. In fact, I could put a number in integers in here, which is really useful because most programming languages, you cannot do this. It has to be required to be only these, like, it has to be a certain type. In this case, Python will basically let you put lists within lists even. So for example, if I have like, let's say this list right here, top travel cities, I can actually have cities, let's say meta, and I can have a list of a list. And then I can have like numbers in here too. And then if I do this now, you can see I have a list of a list. So this first list is that, and then I have 1 and 2. So Python's very versatile, which can actually cause you some issues in the future. But just be aware that you can basically put whatever you want in a list. You can even have an empty list. So if you have something like this, this is an empty list, and you'll see that that's an element by itself too. Okay. And then we can start referencing in the list these different elements. Note that we start with 0 on Python. So basically, in most programming languages, we start with 0 as the first number. So this 0 right here will basically be Solta, okay? And then we can do the same thing for different numbers. For example, if I wanted to do like the 5th one, or sorry, the 6th one, because it starts with 0, 0, 1, 2, 3, 4, 5. That would give us Albuquerque. Does anyone know what would happen? Let's see how long this is. So one thing we can do too is we can actually do, say how long the list is, right? This gives us 11. So does anyone know what would happen if I give it the 11th, number 11 in here? In this case, that would actually be the 12th element, but there's not 12 in there. Does anyone know what that would do?
It will say something like out of range.
Okay, I think
They give you an error?
I think you guys both said the same thing. So yeah, it would give you out of range. It gives you an error. So index error in this case. This is index out of range. So this is a quick thing. What's nice is Python will try to say, hey, I think this is where the error is happening, and it'll point you to the part of the code. So if there's multiple lines, it's really useful. Okay. So there's some fun stuff you can do with indexing. So again, I kind of showed you some stuff. Right here, index slicing. Have you guys seen this before? Thumbs up if you've seen index slicing. Okay, cool. So I won't really go too much in that. Basically, you can get multiple elements in here, right? So in this case, I can get the fourth element onward, or sorry, the fifth element onward, right? We can also do things like getting from the beginning to like number 4. So you can see we get 0, 1, 2, 3. So note that this part does not get counted. If I wanted the whole list, I could also have done this, which doesn't really be that useful. There's some fun stuff you can do with indexing too. You can also do negative numbers. So does anyone know what -1 would give me?
The last.
Last one.
Last one.
Perfect. Right, give me the last one. So you can actually do some kind of fun stuff. For example, if I want to go to the third to last element, and I want, from the sixth element to the third to last element, I can do this way too. I have negatives in here. I can have also done it like, let's say -5 to -3. You can see that part. This is going to be a little confusing in this part. Notice that Sulta is the first element in here. I can also count backwards. So one way you can think of this, like, okay, I start from 0 and I go to the 11th, which will be the end, right? And then I count backward. This last colon right here will tell us to go backwards, or telling us how we should count. So I can do -1, and that will now, oh, sorry guys, I just realized. Wait, what? Am I doing this right? Sorry guys, I just realized. Oh, I must have miscounted the number of elements. But basically, you can say the first one to, let's say, the fifth one. Oh. Sorry, see, I'm making mistakes too. So note that because I'm counting backwards, I'm counting from here to this part. So because I had it flipped over and it's counting backwards, saying start from this first element, well, starting from that first element, there's nothing after that point. Another shortcut just to quickly make a list backwards is basically going from here to here. And this basically represents going from the beginning to the end and then counting backwards. So you can see Sulta now is at the end. We could have also done things like count by 2, so every other element. So you can see it goes from here, skips over this one, goes to this one, skips to this one, goes to this one. So you can do some really interesting things with slicing. The reason why I'm putting this out is because when you look into something called Pandas, Pandas will actually use this packaging, and the way we kind of do slicing in Python will be very similar in Pandas as it is in actual Python. It's kind of like an extension. Okay, and then we have some other extra stuff. So you can kind of go through this, yeah. So you can kind of see some extra lists. We have print A. We'll do multiple elements. So print A will print out the letter A and then the list here. Print the letter B and then the list that is B. And then in this case, we can actually do extend. There's similar to like how we did title. We can basically do certain elements on that, or certain methods on that list. Okay, so you can see, for example, it prints A, prints B, and then it says new A, which is just a string here. And then what happened here is that we did an extend, which in this case, which just basically, you can look at it right here, it extends out, it adds a list to another list. We also have append. If we did append here, let's say do, I'm trying to think of something so we don't mess it up. But let's do like print B. So let's do b.append, oops. And then we're gonna append the number 42, okay? So now this will happen, it'll append that onto the list right here. So we can do things like if you're going through a bunch of things and you want to add to the end of that list, we can do append. You can do a bunch of other things too with lists, but kind of just showing you what that looks like. The last one that's not shown in this document that was made is tuples, and tuples come up quite a bit, so I kind of want to show what that is. So if I have like a new tuple, I'll call it A again, which will just overwrite it. This basically is like a list, but it's something called immutable, which means you can't change it. With a list, I could keep adding to it. For example, I could do append, stuff like that. When I set A, I can't do an append. So you'll see that A, basically, this is a tuple right here. If I do .a.append, it won't let me do that. It says, oh, tuple has no attribute append. It turns out you can't actually add to it. There's no way to actually add to a tuple. If you want to add to a tuple, you essentially have to make a new one. And note that it's called a tuple, which means to see like, oh, tuple 2. You can actually have as many elements as you want on a tuple. So
I have a question about it.
yeah, go ahead.
How does Python know it's not a list and it's a tuple?
Yeah, so the reason why it comes down to the fact that it's brackets. So right here in a list, it's a square bracket. In a tuple, it's actually parentheses. And note that, you know, we could have done something like this. Well, I'll show you real quick. Let's do type A like this, a tuple. If I had done something instead like 1 plus 5, this isn't a tuple. Python's smart enough to say, oh, you just mean that's a math thing together, and you'll see that math, it'll just be an integer. So that's the kind of distinction. But the reason why I want to show you guys tuples is because one thing what you'll see a lot is, I'll just say like answer. It's some functions, which we'll talk about, will return a tuple, and you can actually unpackage that really easily. So for example, this answer right here, that is a type tuple. Answer. Okay. And then let me make sure we print out our answer, right? So you can see that's the actual value. It's a type tuple. But we also, oops. We could also unpack it. And what I mean by that, we can say, okay, let's say x comma y, and that's equal to answer. And because answer was a tuple of 2 different elements, it will actually understand, oh, you want 1 for x and 5 for y. And so now I can actually print out, you know, I'll just print x and then print y. And you can see I get those 1, 5. And in fact, if I do like its type, you'll see that x is actually an integer. Okay, cool. Makes sense. Just know that you'll see this kind of like packaging like this in Python quite a lot, and people go, wait, what's going on? And basically it's unpacking something that was a tuple. Note that you don't have to do this. Usually you'll see x comma y, but it would do the same thing. It would also keep x in there. So, but in Python, we tend not to put those parentheses because it's kind of obvious, like, oh, it's a tuple. So we won't do that. Okay. Cool. Any questions on tuples? Anything about list or anything like that? Cool. All right. Thumbs up so far? Okay. Get a little tricky now. All right. So dictionaries. All right. Thumbs up if you've seen a dictionary already. Feeling pretty good about it. Cool. All right. I'm just going to quickly review that part then, just to say what they are. So dictionaries are basically similar to lists, but instead they don't have any order. But you use a key and basically you have a key and a value. So the way we can create a dictionary is with curly braces. So we'll use this a lot in our package called pandas. And so for example, so S is equal to a dictionary. And note that I could just kept it empty. It doesn't really do anything fancy. Again, its type is a dictionary itself. Okay, so kind of useful, right? But I should say useful. We haven't done anything with it yet, right? But what we can do now, we can actually put it in that dictionary. For example, our key. So I can say like, oh, our key is like K. And then its value is like, I don't know, 12. Okay. We can also have other parts in the key. For example, we can have numbers. So we can have like 4, and then that's referencing to, I don't know, the value 10. So our key is 4, our value is 10, right? And I can also have done 4, and this is going to list to the number 11. Okay. And note that they didn't have to be numbers. I was just kind of putting something in there. You can put even a list in here. This could have been like a list of 11, 12, 13. You can basically put whatever you can put in a list, you can also put in a dictionary as a value. Okay. So now if I print this out, you can see I have my key here, my values, and I can reference these keys, for example, like this, my K. For example, if I put number 4, if I put the number 4 like this, what should print out?
10.
Perfect, right, 10. And then if I have a string of 4, that would also put out a different kind of 4, okay? Quick question, what happens if I put the number 5? Nothing, right? it'll give us an error. It says, hey, you can't do that. I don't know what that is. So one thing you can do, another way to get dictionaries, you'll see this a lot, is .get. And so for example, I can do a .get 4, and that will just give us 10. But if I wanted to do 5 here, I could actually give it a default value and say, oh, well, if it's not in there, say it's, let's say, none. It's not there. Okay, and you can see that way, in case there is a function, if there is nothing there, it'll give me a default value. Otherwise, if I put a 4, which is in the dictionary, it'll give me the actual value. Okay, so some kind of quick things that you can see for dictionaries. Another one that you'll see a lot of is if I want to get just the list of keys, I can do s.keys, which kind of, I'm going to show you something that's not in our, it's going to lead into our control structure. But basically, this is a list of all the keys. So for example, I can do, I'm trying to make it too complicated. For key in s.keys. Print our key, right? And this basically will print out all the keys, K, 4, and 4 with parentheses. I'll change this to something, 5. Okay. So that's how you can do that stuff. For example, you can do keys. You can also do values, and it'll print out all the values. Note that there's no keys associated with them. I could have also done items. So you usually see .keys, .items, and .values. .items will pass in a tuple the key, comma, value. So you'll see that it'll be K, comma, 12, 4, comma, 10, 5, comma, 11, 12, 13 as a list. Okay. So this kind of leads us to something, for loops, right? And which are control structures. I'm trying to think of things I want to go real quick before we go into it. Thumbs up if you've seen control structures like if statements, for loops, while loops. Cool, we saw this in the pre stuff. I won't go over this part then because this will take me a lot of time going through it, and you've seen it before. One quick thing I should note is that for loops are pretty common in Python. You'll probably see these a lot more than while loops. Note that whenever you do a while loop, you can also do an equivalent for loop by using breaks and stuff like that. In for loops, we'll just tend to use this. If you've done another programming language, you'll notice it's slightly different. You can always think in a for loop that we're getting the first element in this some kind of list, some kind of thing, right? So in this case, this is some kind of list, our set right here, and it's getting each element of that part. Note that, for example, I showed you guys when I did, sorry, if I do s.keys, you'll notice that it gave me some funky thing like this, right? And what's happening here is basically a special kind of thing. We'll also do things like, for example, if I do range 10, you'll see that there's this funky thing. But if I do something where it's within here, for example, I print K for range of 10. Okay, what's going on here is basically this will list through, this will go through all those numbers. It's basically getting each element in that range. So just know that it has to be what they call list-like or array-like in order to do a for loop on it, okay? And basically you're getting this in part in there, okay? One thing we'll talk about too later is Lambda functions, not Lambda functions, list comprehensions. And note that this is a way to write a for loop very quickly to make a list. I think I'll save that for next time. I won't complicate things. But if you're curious, list comprehensions, oops, this is not code, so let's here. I want a new one right here. List comprehensions. Oops. I can't type today. So list comprehension, you can basically create a list. And so for example, if I want to do, let's say I'm just gonna say this L is equal to I times 2 for I in range of 10. This will go, the range of 10 will go, like we saw, 0, 1, 2, 3, 4, 5, all the way through 9. And then it's basically, you can look at this part of, oh, this is saying for I in range of 10, it'll go, okay, the first one's 0, the next one will be 1, and so on. When it takes that I, right, it'll do, okay, I times 2. Okay, and this will actually create a list. Now, basically 0 times 2, and then I'll go to the next one, 1 times 2, 2 times 2, and so on. And so this will actually be 0, 2, 4, 6, 8. Note I could have also just done for I in range of 10. And then I can do something like, let's say L is equal to this. So I have it set up. Say, okay, L is an empty list. And I could have done like L dot append I. And that will give me the same thing. And just to prove it, I'll get rid of this. And you can see, oh, okay, times 2, right? So same idea. Okay, just know this is another way. We'll do this more often. I really like list comprehensions, but we'll talk about that in the future. Okay. And then the curriculum also talks about a ternary operation, but I won't talk about that because we won't need to look at that right now. Okay. Any questions on any of the stuff that we just talked about? Cool. Thumbs up. All right. Hopefully it's all review stuff. This is week 1, right? It's nice and easy. Okay. So next thing we're going to talk about is for functions. So I'm going to ask you guys. So how are you guys feeling with functions? Can you create a function? Like thumbs up if you know how to create a function. Okay. Thumbs down if you're like, I don't know what you're talking about. Creating functions. Okay, good, half and half. So this will be good practice. So this is actually in section 2 now, but I did want to kind of show you guys what that looks like. So I'm going to create a few things. So we can actually create functions. And just like we saw in this part right here, when we do this like range 10 or this print, right? For example, we could do things like, print 1. This right here is a function in Python. Basically, it's a built-in function, but it's a function, okay? So we can actually define our own functions, whatever we want. So we can do this by basically saying define df, right? And then we can name our function. So what should we name this function? Give me anything. You can just shout it out, doesn't matter. Silence, all right, silence it is. So we give you guys silence, all right? So we're defining a silence function, right? And we want it to do something. And so this is actually really useful if you're kind of doing the same thing over and over and over again, right? So we can do say, okay, define silence. In this case, I want to print, all right? So basically this will print every time I call silence. And I run this now and you'll see nothing happens. And that's because we haven't called the function, we just defined it. So now to call this function, oops, we can actually call silence with those parentheses, and note that we don't give it any parameters. That's kind of a function with no parameters. Okay, we'll talk about what that is. And now if we're going to call this, it'll always print shh, all right? In fact, I could do some fun stuff. For example, I could do multiple lines. I could do, you know, print shh, quiet, okay? For better, okay? So now I have the silence, and now it will print out that every single time I do that, okay? So this is kind of like the idea of a function. You can obviously get very, very complicated functions. It allows you to basically do the same thing over and over again. The idea kind of in computer science is like, if you have to do it more than twice, you should write a function for it. So you don't have to keep it over and over again. Now this is great, but let's say it's like, well, okay, that's cool, but like I wanted to do something else. For example, let's say I want to say someone's name, you know, let's say like, you know, so Victor needs to be quiet, okay? Which is awesome, right? If you want to tell me to be quiet, but let's say I want anyone to be quiet, right? I want to call a function and say, you know, tell someone to be quiet. So now we can actually create a function with parameters. And what that means, it makes it just that much more flexible. So what we can do here, I'll say silence, I'll just call it silence again, and I'll call it silence too. So our second function over silence. I'm very creative like this, okay? So in this case, I'll say, I'll put in a name and say, okay, for that name, I'll do the same thing with print like that, and then I'll do print. And then what we're gonna do is basically say someone, I'll leave this as blank right now, needs to be quiet, okay? So obviously we want this guy, the idea is like if we have a function now, kind of looking ahead what this would look like, if I called silence 2 like this, and I gave it the name, I don't know, Joe. I don't want to use one of your guys' names. So if I call Joe or something like that, the idea is it would print out shush, and basically the name Joe needs to be quiet, right? So we need to kind of figure out how to do this. So one way we can do it is with something called f strings. So have you guys seen f strings yet? Thumbs up if you've seen it before. Cool. All right, some people haven't, so that's awesome, because f strings are amazing and they just make life so much easier. Note f strings, you have to have at least, I think, version 3.6 for Python. I could be wrong, but so note that if you have a lower version of Python, f strings aren't going to work and you have to do something else. But if not, they're actually really useful. So the way it works, basically, you write a normal string like normal, And if I took out this F, a normal F string, what this would look like, it just prints out this part. Not that exciting. But what I want to do is actually use this variable. So we can actually make an F string by putting an F in front of the string, F strings. Computer scientists are really creative like that. Okay? And we can say, all right, whatever this name is, whatever this variable is, just use that variable in the string. And you'll note that I have these curly braces in here. So it basically says, oh, this is Python code. If I didn't have these curly braces in here, it would just print out name, and that's not what I want. So I actually want this part right here. I print this out, and I say silence to Joe, and Joe needs to be quiet. If I want to say, I don't know, I just randomly put in letters. I don't even know if that's its name. But you can basically put in whatever you want in that case, okay? In fact, you can do some really fun stuff with parameters. So one thing you can do is, let's call this silence3, okay? I can actually put default parameters. So for example, you say, you know what, if you never put in a name, just say it's Victor. You know, Victor needs to be quiet more often. So I can actually put here silence3, and I could normally put in like a parameter, like Babbitt, right? And this will, oops, I didn't run this part, define that silence3. And now when I run it, it will say Babbitt needs to be quiet. But if now I take this part out, what's it gonna do? Anyone got a guess?
It goes back to
Victor needs to be quiet.
Tell us, yeah, so we'll see. I think you guys said it, but you guys got all excited talking over each other. So yeah, it says Victor to be quiet. So it's a default parameter, right? And you can actually have multiple parameters. For example, you can have Victor needs to be, so I'll say like needs to be. Okay. And then actually, one thing I should note is that the name parameters, so when I have a parameter like this, it actually has to be always last. If I don't have that in there, it'll give me an error. So if you swap those names and stuff like that, it'll say, oh wait, I don't know what you're doing. Basically, the default parameters have to be very last. Okay. Otherwise, this doesn't need to be. So needs to be. So this will be saying, okay, whoever the name is needs to be, and I'll go ahead and make this part of the F string. Okay. So now I have multiple parameters. So now I can say, okay, if I want them to be quiet, and I want their name to be Nova, okay? And see, Nova needs to be quiet, or I could change this to like, needs to be Q, whatever that's supposed to mean, right? I could also have gotten rid of this now, because it's a default parameter, it'll just say Victor here, and I'll say, okay, it says needs to be Q. Note if I don't use this part, because I didn't give it a default parameter, it'll give me an error. It says, oh, it's missing a required parameter, okay? So this is why you can create some functions. It's really useful. You'll do this in like our little quote unquote project in the end of section 2, which is to create a calculator. Real quick while I'm on this, when the curriculum says like projects, labs, lessons, and stuff like that, so you'll sometimes use like labs. Note that I'm not gonna like grade them in that sense. Like they're more like for you to do and check out, and there's solutions there which you can use to kind of help you along. But you should definitely, even if you look at the solution, don't just go in the solution and just like copy and paste it and just go with it. It's important to actually, you know, try it out, and then if you get stuck, there's no shame in looking at the solution and seeing what they did, maybe copying it and then like trying to run it and then saying, well, okay, how did that work? And then adjusting it. There's nothing wrong with that. Like that's a great way to learn. But just know that when we see the project on there for the curriculum or labs, I think the only one that says project is really section 2. Those are not graded. Those are just basically for your practice and education. When we will have a project. Our project will be about 2 months from now. And I'll make a big deal out of it. I'll say, oh, we have a project coming up. There's a whole project week. So just know that our section 2 quote unquote project on there is not an actual project. It's more like just like a bigger lab. So just the terminology is a little different. And I think that changes after this curriculum. So anyway, so this is where you can use functions to call over and over again. For example, when you do your project on section 2. Cool. Any questions on this guy? All right, cool. So the last part in section 2, which I'm debating if I should really actually go into, I think I might save this for next time, but I'll kind of briefly talk about it, is the part in section 2. So you'll see right here for section 1, you guys will go through all the stuff in Python. Hopefully most of it's pretty, review. They'll talk about visualizing data and stuff like that too. So that's really useful to actually know what's going through. But section 2, you basically see some stuff like functions, operators, which I kind of showed you right now. And then basically control structures like while loops, for loops, all that stuff. A lot more detail in there. So if you really want to know more, definitely go through the curriculum carefully and see what parts and mess around with it, see what works and see what doesn't work. But as we go further, the second half is basically about statistics. So you can see here, for example, central tendency, dispersion, and then just general statistics. That's in that. I didn't go into this, but this is actually in the study group. I'm sorry, inside the resources in this M1S02. This is actually what it is right here. I'm trying to remember exactly what it looked like. So let me just pull that up. And I'll open with Collaboratory. So I think the first section of it, okay, no. So yeah, you see this part right here is basically some summary of some dispersion, stuff like that. We might talk about this for next time on Tuesday for our study group, just to kind of quickly review it. But basically it's the mean, the median, the mode, what those means, and what skewed means. As data scientists, we're going to be looking at data a lot, which data basically means statistics. We're going to be using statistics to help summarize information. The way I kind of describe statistics is every time we're doing a statistics, we're really trying to summarize some data to make a better to get a better understanding of what it is without looking at every single individual point. It is a fact that like the data are just a bunch of points, right? They're a bunch of values, but reality is just people just, you know, as people, we're not good at looking at a list of numbers and understanding, oh, I can clearly see there's a pattern here. So we use statistics, basically different metrics, to help us form a picture of a summary of what's going on. But note that it's always a summary. It's never the full story of the data. So you should always look at statistics when you see like those numbers like mean, median, mode, standard deviation, basically measures of dispersion, and even more advanced numbers. For example, we'll talk about for skewness and kurtosis and like all these other things and t-statistic. All these things are wrapped around to help describe the data for us so we don't have to look at every individual point. Another way of doing it, it's kind of like the non-quote unquote mathy way of doing the statistics is visualization. And I like to say, and you'll hear me say it again and again, is that visualization is really about you presenting things, so a summary for people, but also it really helps as a person, for whatever reason, evolutionary reasons why, we have a pretty good job of seeing visual patterns. And that's where basically visualizations really come in. So when we plot something out, for example, you'll see scatter plots a lot. It's a lot easier for us as people to quickly look at it and say, I think I see a pattern in here. Now that doesn't mean that you ignore all statistics and you just look at data points and stuff like that. But it can help give you a hunch or help you guide you in the right direction, saying, okay, what is this gonna look like? Let's see here. There is a famous one. I'm trying to remember, I always forget it. Oh, stats. I'm gonna look at it and I'm like, of course. Inscombes. That's why I can never say it because I can never pronounce his name. There's a famous quartet here, and this is the actual picture right here. And so you'll notice that there's all these data points. So first of all, looking at that, it's clearly very different from each other, right? Each graph here represents a data set, and each of those data sets are very different. For example, this is more of a randomly, this is actual curve. This one right here is a straight line, but then a strong outlier right here. And then this one's like pretty much everyone's at 8 except for this one guy right here. Well, the funny thing is that I believe these ones have the same metrics. For example, it has the same median, it has the same mean, and I think it has the same mode, if I remember that right. So like, and it's within a rounding error. So the problem is that these numbers, these values that we use to analyze this data set, basically are nearly exactly the same. And that's where like really looking at a plot, looking at it visually, as a person, you immediately see that pattern and say, that's clearly different. But if you just printed out the numbers, like calculate the median, calculate the mean, never looking at the data, you wouldn't see that pattern, or at least it would be harder to find that pattern that's there. So this is why I always emphasize that, looking at the data is not, I think in data science, we tend to be very analytical, which is very good. We should be analytical. We should be very precise. But I think sometimes there's a tendency not to look at those things at more like, I like to say like the human side, which is my kind of like floaty, like, humans, we're so important. But I really do think it's an important thing to use our human brain. Like we have a pretty decent brain that can figure out a lot of things by looking at stuff and helping us guide further. And of course, once we see this stuff, then we proceed further into more analytical tools that we can give it more and more details. But without looking at it, it's a lot harder to see those parts. Cool. All right, so that's kind of like my little soapbox that I'll kind of sneak in every once in a while. But again, this is in the resources here. And like I said before, I think the second half of it, like this part, this list indexing, this list methods, that's just from the section 1 resources. So again, this guy right here, this is in the resources for the student resources page, that spreadsheet. And I'll keep adding, like this recording, for example, will be added in there. Okay, cool. All right, so that kind of ends up where I'm at. Not quite over yet, so that's good. All right, sometimes I'll talk forever, so just stop me if I ever talk too much. All right, but any questions I think you guys have to ask? Cool, all right. Someone unmuted? No? Okay. All right, so I'll go ahead and stop the recording now.